Hello and welcome to this specialization on TensorFlow 2 for Deep Learning. My name is Kevin Webster and I'm a Senior Teaching Fellow in the Department of Mathematics at Imperial College London, and I'm delighted to be here teaching this course. I'm also joined by a fantastic team of graduate teaching assistants who are PhD students here at Imperial, and they'll be helping me throughout the course to guide you through all the amazing things you can do with this library. TensorFlow is one of the most popular libraries for deep learning. It's a project that was released as open source by Google back in 2015, and it's widely used today amongst researchers and professionals at all levels. There are a few things I'd like to emphasize and make clear right at the beginning about this course in this video. The first thing is that this isn't a course on deep learning. It's going to be assumed that you already have knowledge of deep learning models, and this course is really just about learning TensorFlow 2. The second thing I'd like to emphasize is that this course is intended for both people who have worked with TensorFlow 1 before and people who are completely new to TensorFlow. You don't have to have had any prior experience at all in order to take this course. And just in case you're feeling daunted by the prospect of local installations or working on remote servers or training on GPUs, you don't need to worry about any of that in order to learn how to build, train and use deep learning models in TensorFlow. In this course, everything that you need is available here on the Coursera platform, and you can complete the course entirely through the browser. The way this course is structured is a combination of lecture videos and practical coding tutorials, so you'll be putting all of the content you learn about into practice straight away. You'll be developing deep learning models for a range of applications, including image classification, text sentiment analysis, regression tasks, and generative language models. At the end of each week of the course, there'll be a programming assignment where you'll need to apply the concepts you've learned from that week. The programming assignments are all in Jupyter notebooks, and you'll complete and submit them entirely through the Coursera platform. In addition, at the end of each one of the courses in this specialization, there's a capstone project. These capstone projects are extended projects that will include material from throughout the course to stretch your knowledge of working with TensorFlow even further. The capstone projects are peer assessed, so you'll be able to give and get useful feedback from your peers. So I hope this gives you a good and clear idea of what this course is about and what you can expect. I really hope you'll find this course useful and a lot of fun to work through. And I'm looking forward to seeing you in future videos. Hi, and welcome back. In this video, I'd like to set the scene for what we're going to be looking at in this week of the course. The first week of the course will be a different format to the following weeks, and that's because before we start diving into learning TensorFlow 2, I'd like to give something of an overview of some of the important developments and concepts, differences from TensorFlow 1, and introduce some resources and tools that I think you'll find really useful, such as Google Colab, and of course, the TensorFlow documentation. There are also several items this week that you'll see are marked as optional. These items cover things like how to install TensorFlow on your local machine, or different ways that you can use TensorFlow, or how to upgrade code you might have written in TensorFlow 1 to be compatible with TensorFlow 2. Now, you don't need to work through any of these optional items in order to take this course. As I mentioned in the introduction video, you can complete this course entirely through the browser. These optional items are included as extra resources to those of you who would like to make use of them. You can feel free to skip these items if you want to. You can always come back to them later on if you want to prepare your own setup. There's also no programming assignment in this first week, but there will be one at the end of every week from next week onwards. So, that all being said, let's get started. From next week onwards, the structure of this course will be a combination of lecture videos from me, where I'll be explaining and presenting the different features and objects in TensorFlow, and coding tutorial videos given by one of the graduate teaching assistants, or GTAs, where the material I'm presenting will be coded with examples into a tutorial notebook here on the Coursera platform. In these coding tutorial videos, the notebook itself is available to you as a separate item in the course shell. You can open up this notebook in a separate window, so you can code in the examples yourself as you follow along with the GTA in the tutorial video. This is great practice to get comfortable with coding things up in TensorFlow for yourself. The coding tutorial video and notebook immediately following this video will give you a taster of how this is going to work. This is going to be the format for much of the course content following this week. So please go ahead and open up the following coding tutorial video and notebook, and Jerome will take you through a first Hello World example in TensorFlow 2.
Hello and welcome to TensorFlow 2 for Deep Learning. My name's Jerome. I'm a PhD student here in Imperial College London's Maths department. I'm also one of the GTAs that will be running the coding tutorials for this course. Delighted to meet you. As Kevin has already told you, in this lesson we will go through a Hello World example in TensorFlow. We'll import TensorFlow using a Coursera notebook, we'll check its version, and then we'll run a short script that trains a neural network. Let's get started. Open the Coursera notebook for this lesson. You should see what I have on the screen now. Start off by importing TensorFlow and checking its version. To import TensorFlow, write import TensorFlow STF, then press Shift and Enter to run the cell. In the cell beneath, type out tf._version_. Press Ctrl and Enter to run the cell. You should find that you've imported TensorFlow version 2. The cell at the bottom of this notebook contains code that creates and trains a neural network to classify images of handwritten numbers taken from the MNIST dataset. Don't worry about the details of this code for the time being. You will understand it by the end of next week's lessons. All it does is load a dataset, declare a model, and train that model. Run the code by clicking on its cell and pressing Ctrl and Enter. The dataset should take about 30 seconds to load, so be patient. Maybe make yourself a cup of tea. Once the dataset is loaded and the model begins to train, you'll see a printout informing you of the model's training progress and its performance. When the model is finished training, the printout will tell you that the model is trained successfully. Congratulations! You've just trained your first model using TensorFlow 2. If the code in this notebook is unfamiliar, don't worry. The concepts underpinning it will be discussed in future lessons. In this lesson, we were simply checking that you could run TensorFlow 2 on Coursera. I'll see you in the next tutorial.
Welcome back. In this video, I'd like to talk about some of the big changes that have been made in the version 2 release of TensorFlow. As I mentioned in the introduction video, TensorFlow 2 is a big step forward from TensorFlow 1, and the focus from the TensorFlow development team has been on making it really easy to use, without losing the benefits that the paradigm of TensorFlow 1 gave us. Also, I just want to repeat one point from that video, which is that you don't need to have used TensorFlow 1 before to succeed in this course. But even if you haven't used TensorFlow 1 before, you might find it useful to know a bit about how your code would have been organised in this earlier version, and why, because it will illuminate some of the advances of TensorFlow 2 and give you more of an idea of what's going on behind the scenes. If you've ever worked with TensorFlow 1 before, then what you can see here might look familiar to you. Straight away it looks quite complicated and confusing. In TensorFlow 1, you'd first have to set up the variables and the operations that define your model, as well as maybe a loss function and optimizer you want to use to train the model, so that everything is in place before you can actually run anything. So you couldn't immediately use these variables w and b that I've created up here. Instead, these variables and operations would define a computational graph that basically says how the inputs, outputs, and parameters of your model are all connected. And you'd also have to define these things called placeholders that serve as entry points to your computational graph where you can feed the data into. Once the graph is built, you could then run the graph inside something called a TensorFlow session. But first you'd need to initialize your variables before you could use them. Then you could run the training operation and calculate the loss, passing in the data with something called a feed dict. TensorFlow 2 does away with a lot of these complications, so I'd like to summarize some of the major developments in TensorFlow 2 that makes your workflow a lot easier. Eager execution already existed in TensorFlow 1, but in TensorFlow 2 this is now the default behavior. Eager execution means that TensorFlow variables and tensors can be used straight away. There's no need to run an initializer or to launch one of those session objects to get their values. It sounds like such a simple thing, but this is really quite a big change from the whole graph building and running in a session paradigm. In TensorFlow 2, Keras has become the default high-level API for TensorFlow. So the complete Keras API is now wrapped up as part of the TensorFlow installation and has become seamlessly integrated with TensorFlow. The nice thing about Keras, as we'll see later in the course, is that it's really easy to use, but it's still very flexible. Even though I say it's the high-level API for TensorFlow, you'll be able to do most, if not all, of your model developments using Keras. The final thing I want to mention is that the API in TensorFlow has had quite a lot of work. Before, there were a few inconsistencies and things like functions in different places doing very similar things and so on. In TensorFlow 2, this has been considerably cleaned up. As you'll see later when we take a look through the documentation, it's nicely organized into modules and it makes it much easier to find what you're looking for. There's of course a lot more that's new in TensorFlow 2 that I haven't touched on here, but I wanted to highlight some of the major changes. As I say, even if you've never worked with TensorFlow 1 before, I hope this gives you a bit of context for TensorFlow 2 and also gives you a sense of what's going on in the background. Remember that with the graph building paradigm, the main purpose is to optimize the code so that it runs faster. In TensorFlow 2, this is actually still happening, but it's happening behind the scenes, for example, when you use the high-level Keras API, so you don't have to worry about it. But when you become a more advanced user of TensorFlow and start writing lower-level code, you'll see later on in the course how you can still gain the benefits of compiling parts of your code into a single graph for performance gains. So it's helpful to at least be aware at this stage of the graph compilation that's going on in the back end of TensorFlow. I'll see you in the next video. Welcome back. In this course we're going to be exploring TensorFlow 2 and some of the amazing things that you can do with it. As I mentioned in a previous video, TensorFlow 2 is quite a big step forward from TensorFlow 1. And so to help us explain some of the changes in TensorFlow 2, I'm delighted in this video to introduce Laurence Moroney. Laurence, thank you for being here today.
Thanks for having me.
So I'd like to talk about some of the features in TensorFlow 2, but before we get to that, maybe you can talk a bit about what you do now. So you're an AI advocate at Google right now.
That's right, yes. So I lead a team of what's called scalable advocates for AI at Google. We've got a number of folks around the world where our job is to inform and inspire developers around the world, as well as advocating for them. So as Google are building our products to make sure that we build it how developers want it.
Okay, so tell me a bit more about how it all started for you. How did you get into AI in the first place?
Well, that's actually an interesting and very long story. And it was, for me, it began with an experiment run by the British government way back in 1992. You know, and I know you're from England, so have you heard of us?
No.
I'm putting you on the spot. So back in 1992, England was in the midst of a pretty big recession. And the government was planning various schemes to get out of recession. And one of the things was they identified that AI was a possible thing for industry of the future. So they wanted to find 20 people. And I grew up between Ireland and Wales, and I was living in London at the time. And they wanted to find 20 people who were qualified, who had college degrees, but who were unemployed. And I was one of the 20. And to train us up in AI, and then we could maybe be the spearhead of a future set of consultants or startups or something like that to help industry with AI. Unfortunately, it failed, but I got bitten by the AI bug. And so then a few years ago, while I was working at Google, the bug bite came back, and I was working on a product called Firebase. And Firebase has a technology called Firebase Predictions. So if you're building a mobile application, you can use Firebase predictions to predict things like when your users are going to churn, or maybe when your users are going to do in-app purchases, that kind of thing. And that uses TensorFlow as its underlying technology. So I helped launch Firebase predictions. Then I got bitten by the AI bug, like I mentioned again, and I was able to go and join the TensorFlow team, and here I am.
That's great, great story.
Thank you.
So over the years, you must have seen a lot of changes in the technologies that ML researchers are working with. How do you see the impact of technologies like TensorFlow? How has it changed machine learning and deep learning research and the way we do it?
I think the biggest impact for me is to widen access, to give it accessibility to AI and AI technology to far more people. Like I mentioned, for me, back in 1992, I was part of this core group of 20 people that the government had selected, and it was a massively privileged position to be in because the technology, and it was like Prolog and Lisp, and compilers for that were very expensive and very few people could do it. Nowadays, technology is a lot cheaper, and things such as Python are open, and TensorFlow is open source, so that far more people can be involved. And having more people involved trying to solve any problem is always a greater way of solving a problem than having fewer people involved. So to me, I think that's been, beyond the technology, one of the biggest impacts has been, the fact that it's open source, that it's free, that anybody can start using this.
Right. And so talking about TensorFlow 2 specifically now, what do you think are some of the big changes, big developments that excite you the most?
So I come from a software development background, so it's going to be viewed through that lens. And so TensorFlow 1 was terrific in that, but it was very oriented towards researchers. It wasn't very intuitive to a typical software developer to load everything into a graph and then execute that graph. We're used to executing line by line. So with TensorFlow 2 being eager by default makes it a lot easier for the general software developers. And there's a stat that I always like to cite that research showed that there were about 300,000 AI practitioners in the world, but there are close to 30 million software developers. And if we can build a product and a platform that appeals to the 30 million as well as the 300,000, that to me is the kind of thing that busts you out of the hype cycle, that makes it a real thing. And there isn't another AI winter from 1992 until nowadays that if you have it becoming part of the de facto toolbox of the 30 million people. So to me, that eager by default in TensorFlow 2 is the #1 feature that excites me.
Yeah.
And then of course, on the theme of widening access and making it easier, things such as Keras. So being able to define neural networks using Keras layers, to be able to define an LSTM with one line of code and that kind of stuff, again, on the theme of widening access, making it easier for people to be productive with machine learning is what I'm most excited about.
Right, that's really cool. And so looking to the future, what do you see as the future direction of AI and TensorFlow and so on?
Yeah, so I think the future direction is the continued widening. Right, more and more technologies coming into it, making them easier for developers to use. I know you're going to be teaching about probability in this course, so things such as probability 2-3 years ago, you probably needed a PhD just to understand the documentation, but having APIs that make it easier for people to be able to use things such as TF probability, and you'll be chatting with Paige about that in a later video, which is really exciting. And so that to me is where the future I see is going, that general level of widening access, plus the ability to deploy your models in new places. So being able to deploy models to mobile devices, so you can now have inference in the palm of your hand, being able to have cheap and easy deployment of models to the cloud so you can scale to billions. And that type of thing means that it's out of the hands of the few and into the hands of the many. And when that starts to happen, that's when the magic really grows. And
that's great.
Hopefully that's the road that we're on.
Yeah. Well, Laurence, thank you for joining me today.
Thank you.
One of the resources you should definitely be aware of that makes it really easy to develop with TensorFlow, as well as other libraries, is Google Colab. If you haven't heard of Colab before, what it is a research project by Google that was publicly launched in 2017, and it provides a free cloud-based service where you can write and run Jupyter notebooks entirely through the browser. The really cool thing about working with Colab is that you can get up and running with it straight away. Many of the popular libraries that you might want to use come pre-installed, including TensorFlow. And if you want to install additional packages, you can also do that. So it takes a lot of the pain away for you. And it comes ready with a GPU that you can use for your networks. And this makes a big difference when it comes to developing deep learning applications. As to train large networks and use large datasets, you really need accelerator hardware. We've made all of the coding tutorial notebooks in this course available on Colab, as well as on the Coursera platform. Now, it's not necessary for you to use Colab for any of the course. You can complete the course entirely through the Coursera platform. But you might find that for some of the more computationally demanding deep learning models that you work with, using the free GPU on Colab saves you a lot of time waiting for networks to train. So in this lesson of the week, I'd like you to familiarize yourself with Colab so that you have it available as an extra resource to work with. The first stop you might like to make is to the welcome page of Google Colab. I've added the link to this page in the resources. This page is itself a Colab notebook, and it already demonstrates some of the interactive features that you get with the notebook environment. Down here, you can see that there are some useful links to resources for learning the workflow with Colab notebooks, including working with Markdown, installing libraries, working with data, and so on. In the following tutorial video, Jerome will demonstrate these and other important features that you'll want to know about when working with Colab notebooks. The other nice thing is that you can use Google Drive to store data that you want to use in the development of your deep learning model and link that directly to your Colab notebook. This is something else that Jerome will demonstrate in the following tutorial. So if you haven't used Colab before, I'd highly recommend to step through the following tutorial video and just take some time to familiarise yourself with it. I'm sure you'll find it a valuable resource. And when you're ready, I'll see you in the next video.
Hello! As you've heard from Kevin, in this tutorial I will be your guide to Colab, Google's cloud-hosted version of the Jupyter Notebook. Colab offers a GPU hardware acceleration that will be useful to you throughout this course and beyond. To reiterate what Kevin said, creating a Google account is free and you'll need one to get the most out of Colab. Let's jump in. We'll pick up right where Kevin left off, with the Welcome to Colab notebook. Sign in to your Google account via the link in the top right-hand corner of the page. Enter your username and password. You are now using Colab with your Google account. To create a new notebook, click File, New Python 3 Notebook. An empty Python 3 notebook should open. Notebooks in Google Colab are saved to your Google Drive. To see where your active notebook is located in your drive, click File, Locate in Drive. You'll then be taken to the notebook's location. You can see that by default, notebooks are saved in a Colab Notebooks folder. To create a Colab notebook while browsing your drive, alternate click, go to More, and then Google Colaboratory. You've probably already noticed that the Colab interface is very similar to that of a Jupyter notebook. Colab does indeed provide similar functionality to that of a Jupyter notebook. For example, you can create a code cell below the active cell by pressing Ctrl-M followed by B. You can switch a cell from code to Markdown by pressing Ctrl-M, then M, and return it to a code cell by pressing Ctrl-M and Y. As with Jupyter, Markdown cells in Colab support text formatting. To write a header, for example, you just need to prepend your text with a hash symbol. If I switch this back to a Markdown cell by pressing Ctrl and M, then Enter to edit the cell, and finally, hashtag Hello Colab. An important aspect of Google Colab is that the notebook runs on a remote machine that is owned by Google. This means that you don't need to have Python installed locally for Colab to work, but you do need a persistent internet connection. If you want to change the notebook's kernel language or the host hardware configuration, go to Runtime, change runtime type. You can then choose between Python 2 and Python 3, and between 3 hardware accelerations. The default instance, None, has 13 GB of RAM but does not have a GPU. The GPU instance, on the other hand, has a Tesla K80 GPU and the same amount of RAM as the default instance. The final instance type, TPU, is a Tensor Processing Unit instance, which offers a TPU rather than a GPU. I won't talk about TPUs in detail now, but you should know that TensorFlow 2 does not currently support TPUs, at least at the time of this recording. This is likely to change in the future. We won't be talking about TPUs on this course. Now let's load some data into Colab. To load a dataset that is on your Google Drive, you need to mount your drive to the notebook. Do this by opening a code cell and typing out from google.colab import drive and drive.mount G drive. Press Shift and Enter to run the cell. Click on the URL that it returns allow access to your Google account, then copy the authorization code into the cells dialog box. Drive will take a few seconds to mount to Colab. You'll know it's done when you can see your drive in the left-hand pull-out tab under Files. You can see that in my drive, I have a text file called hello.txt. I can deduce this file's path from its location in the tree. To load this file, I'm going to use Python's open function. I'll type out my file equals open gdrive /my drive /colab notebooks /hello.txt. To print the contents of the file, I'm going to write print myfile.read. Press Shift and Enter to run the cell. As with Jupyter Notebooks, you can run bash commands inside the code cells of a Colab notebook. To run a bash command, prepend the command you want to run with an exclamation mark. To list the files in your working directory, for instance, you would write !ls and then run it by pressing Shift and Enter. You can use bash commands to install any packages that are not installed on the Colab instance already. If I thought NumPy was not installed, I could install it via the command !pip install NumPy. As you can see, NumPy is already installed on the Colab instance. At the time of this recording, TensorFlow 1 is installed on Colab by default. This will probably change in the future. But to upgrade to TensorFlow 2, run the command !pip install TensorFlow equals 2. The upgrade should take about 1 minute. I sped the footage up to save you some time. When the install is complete, click Runtime, Restart Runtime. Once the runtime is restarted, check TensorFlow's version by importing it and running the command tf:\version:\. We can see that version 2 is now installed. Colab will probably be upgraded soon to feature TensorFlow 2 by default, in which case you won't need to install it each time you launch a new notebook. In addition to creating notebooks from scratch, Colab can open a Jupyter notebook that is on your local machine. To do this, click File, Upload Notebook. You can also load Jupyter or Colab notebooks that are saved on your GitHub. Just go to GitHub. Enter your username and password, and then select the file that you want to load. If you want to download a Colab notebook as a Jupyter notebook, click File, Download.ipynb. You are now familiar with the ins and outs of Google Colab. Who says there's no such thing as a free lunch? If you should find yourself waiting a long time for a model to train on your local machine, or on the Coursera notebook, then I suggest you try the GPU accelerated Colab notebook. I'll see you for our next tutorial.
Welcome back. One of the important resources I would definitely encourage you to make use of throughout this course is the TensorFlow documentation. We're going to be covering many different areas of the TensorFlow library within this course, and the way the course is structured means it's quite self-contained. But I'm sure that you'll still find it useful to go back to the TensorFlow documentation as a reference, to remind you of syntax or function signatures, or to explore more of the options that are available in a particular part of the library. So it's a good habit to get into straight away to familiarize yourself with the documentation. To browse the TensorFlow documentation, just head to tensorflow.org. Along the top here, you can see the link to the API documentation. And by the way, there are some great tutorials and the TensorFlow guide that you can find through this link. So make sure to take a look at those too. But right now, we want to take a look at the docs. And if you hover over the API link, you can see the different versions of the API docs. we're going to take a look at the latest stable release, which at the time of this recording is version 2.0. On the first page, you can get an overview where you can look through all of the modules that are within the library, and you'll see there's quite a few here. Further down the page, there are the classes and the functions listed. If I scroll down to the bottom, you can see the other members where you'll find things like TensorFlow types. Okay, so on the left-hand side of the page, you can find all these classes and functions listed in alphabetical order, and you can click through to see the documentation for any of these. Now, if I just minimize this list, you can now see an overview of the many modules within TensorFlow. There are two modules in particular that I want to draw your attention to, as we'll be using them a lot in this course. The first one is the tf.keras module, which we're going to start using straight away. If we open up this module to see what's inside, you'll see there are some classes at the top here, input, model, and sequential, and you'll see what all of these are later on in the course. And there are more modules I can take a look at within the tf.keras module. And again, you can click through any of these to bring up the documentation. The other module I want to point out, if I just minimize the tf.keras module, is the tf.data module. This is another important module within TensorFlow, and we'll be looking at this further on in the course when we get to talking about data pipelines. So please take some time to explore the documentation, if only for the moment just to familiarize yourself with how it's laid out. You should think of it as a companion resource to what we're going to cover in this course, and I'd always encourage you to look up the documentation for the different objects that you're learning about throughout the course. So with that, I look forward to getting started building our first deep learning models in TensorFlow in the next week of this course. Hi, and welcome back. In this section of the week, we'll take a look at the different options for installing TensorFlow. As I mentioned in the first video of the week, this section is entirely optional. You don't need to install TensorFlow locally in order to take this course, so feel free to skip these videos if you don't want to have to bother with a local installation, or if you already have TensorFlow installed. In my experience of teaching courses, I've often found that installing TensorFlow is actually the first thing that students get unstuck with, and it can be quite confusing as there are a few installation options, and it also depends on the operating system and what hardware you have available. The different options for installing TensorFlow are documented on the website if you head over to tensorflow.org/install. Broadly speaking, the main factors are the operating system you're running, whether it's Linux or Mac OS or Windows, and whether your machine has a GPU available that you'd like to use for training. You'll notice the site also mentions Google Colab over here as well, which is another option for using TensorFlow that we've covered earlier in the week. Down the left-hand side, you can see some different options for installation, and in the following videos, Jerome will walk you through the pip installation and using Docker containers for running TensorFlow. The pip installation is probably the easiest one, especially if you'll only be using the CPU version of TensorFlow if you don't have a graphics card that you want to use. It's a bit more work if you want to install the GPU version of TensorFlow, as there are additional drivers and libraries you have to install in this case. You can find more details about this in the GPU support guide, and you can see the link for this down the left-hand side. The recommended method for enabling GPU support is with Docker containers. If you haven't worked with Docker before, then just to give you a quick overview, Docker is software that you can install and run on your machine, and what it does is to create objects called containers that have an isolated virtual operating system, where, for example, TensorFlow and other libraries can be installed, whatever is needed to run TensorFlow programs. These containers are created from Docker images. The images are what define the libraries and packages that are installed inside the container. You can download the official TensorFlow Docker images for whatever version of TensorFlow you want, whether it's the GPU or the CPU version, or if you want Python 3 support, or a specific version of TensorFlow, and so on. Note that the GPU version is Linux only. The nice thing is that by using these images, you avoid any problems of conflicts between library versions and installation issues that might be specific to your machine or operating system. In the following two videos in this section, Jerome will show you examples of installing TensorFlow using pip into a virtual environment, or with using a Docker container to run TensorFlow. These videos assume that you're comfortable working with the command line and that you've had some experience of working with Docker before. Just to reiterate, these tutorial videos are totally optional. If all this sounds too intimidating, then don't worry about it, just feel free to skip through. You don't need to make a local installation to complete this course. But if it is something you'd like to get set up, then I hope you'll find Jerome's tutorial videos helpful. And I'll see you in the next section.
In this tutorial, I will show you how to install the CPU variant of TensorFlow on an Ubuntu machine. We will install virtualenv, a virtual environment manager, create a virtual environment to install TensorFlow 2, then install TensorFlow using pip, a Python package manager. If you have Conda installed and are comfortable using it to create and activate a virtual environment, then you may prefer to use this instead of virtualenv. I've also linked an install guide in this video's description. Let's get started. Open the link to the TensorFlow install page that is in this video's description. You'll see that 3 TensorFlow 2 packages are available: TensorFlow, TensorFlow GPU, and TF Nightly. The first of these is the CPU-only variant of TensorFlow. This is the simplest to install and is the one that we will be installing in this tutorial. We'll return to TensorFlow GPU in a future lesson. If you scroll down, you'll find that this page also lists TensorFlow 2's system requirements and hardware requirements. You should have Python 3.4 or greater, and pip version 19 or later. To check these, open the terminal and type in pip -- version. As I mentioned, you should have at least version 19.0. To check the version of Python 3, type in Python 3 -- version. Anything from Python 3.4 will work. Download and install the latest version of virtualenv for your user account by running pip install --user -u virtualenv. Virtualenv will then download and install. Next, create a virtual environment that uses Python 3 using the command virtualenv and then the name of the environment that you want to create. I'm going to call mine tf2env. Press enter, and the environment will be set up. To activate your newly created environment, run source, then the name of the environment, followed by bin/activate. You can see that the environment's activated by this parenthetical expression at the beginning of the line of the terminal. You can then install TensorFlow 2 in your environment using the command pip install TensorFlow equals 2.0. If you haven't used a virtual environment before, you may wonder why we are using one. Virtual environments allow you to neatly maintain multiple versions of a single package, or even of Python, on your machine. So if you wanted to, you could have one environment for TensorFlow 1 and one environment for TensorFlow 2. Once the download and install is completed, open Python 3 to verify TensorFlow. Type import TensorFlow as tf to import TensorFlow, and check its version by typing tf._version_. And there you have it. We've installed TensorFlow 2 locally. Knowing how to create and use virtual environments is a useful skill, especially if you use Python regularly. Giving thought to environment creation at the start of a project can save a lot of time later on. This tutorial was entirely optional. You don't need to use your local install of TensorFlow to follow along with the course. If anything, I would recommend using either the Coursera notebook or Google Colab. That way you can save your work remotely, and your local computer's resources will remain available while you run tasks remotely. I'll see you in our next tutorial. Hi, Jerome here again. Last time you learned how to install TensorFlow 2 for CPU locally. In this tutorial, you will learn how to run TensorFlow GPU via a Docker container. I'll walk you through installing the Docker engine, installing your NVIDIA drivers and the NVIDIA Container Toolkit, and creating a TensorFlow GPU container. I'll be using a computer in Imperial's cluster that is running Ubuntu and has access to a NVIDIA GPU in this example. The install procedures that I show you will only work on a Linux machine with a NVIDIA GPU. If you're working on Mac or Windows, then you'll need to install the dependencies of TensorFlow GPU directly. I've included a link in this video's resources that shows you how to do this. Let's start by installing the Docker engine. Open up the first link in this video's resources, the one to the About Docker webpage. Here, select your distribution of Linux in the left-hand drop-down menu. This will take you to an install how-to page, which will tell you how up-to-date your OS needs to be to support Docker, and how to install the Docker engine. I'm using Ubuntu 18. If you're using a different variant of Linux, you should follow the install instructions for it, then skip to the section of the video where we install the NVIDIA Container Toolkit. We're now going to install the Docker engine. Add the Docker engine's key to Apps Key Manager and its repository to the repository index via the first command in the text file attached to this video. Great! apt can now see the Docker repository. Update the package index and install the Docker engine and container using the command that I'm pasting into the terminal now. Once that's done, you can verify that the Docker engine is installed correctly by running the hello world image. To do this, write sudo docker run hello world. This command downloads a test image and runs it in a container. When the container is running, it prints a message and then exits. At this point, you have installed Docker and made its repository visible to apt, so that it will update each time you run apt update and apt upgrade. Let's now install the NVIDIA Container Toolkit. You should already have installed the NVIDIA GPU drivers that you need. If you haven't, you can install the ones that are recommended for your GPU by running the command sudo ubuntu drivers auto install. As you can see, my system already has its drivers installed. To check that the drivers are installed correctly, run the NVIDIA System Management Interface. This will only be able to read the GPU information if the drivers have installed correctly. To launch the interface, run the command nvidia-smi. You can see the GPUs on my machine, along with their usage statistics. Now that we have the Docker engine and the NVIDIA drivers installed, let's install the NVIDIA Container Toolkit. The toolkit allows a Docker container to interact with the host machine's NVIDIA GPU. To install the toolkit, add the repository key and the repository address to apt. You can do this using the command that I'm pasting into the terminal now. Once that command is run, use apt-get update and apt-get install to install the most recent version of the NVIDIA Container Toolkit. If you then restart Docker, using the command sudo systemcontrol restart docker, then you are now ready to run a container that uses your system's GPU. Test that the previous steps have been successful by creating a container running NVIDIA's system management tool, nvidia-smi. You can do this using the command that I'm typing into the terminal now. All being well, this will list your GPUs. The difference between the interface you see now and the interface you saw earlier is that this one is being run from inside the Docker container. This tells us that the container is able to access our GPUs. By contrast, the interface we saw earlier was run directly and did not require the NVIDIA Container Toolkit. Now that Docker is set up and you can use the GPUs, let's run a TensorFlow container. To recap, a Docker image is an executable software package that contains everything you need to run an application. A running version of a Docker image is called a Docker container. refer back to the TensorFlow documentations page on Docker. You can see that several Docker images are available for you to use. You will probably want to use the latest stable version of TensorFlow GPU. Tailor the TensorFlow image that you download using the tags. There are tags to enable GPU support, TensorFlow for Python 3, and include Jupyter. We're now going to issue a command that creates a directory, then mounts that directory to a container that is running a Jupyter notebook. To create the directory, run mkdir, and then the name of the directory. I'm going to call mine my Jupyter notebooks. Then to create a container that has access to TensorFlow 2, is using your GPUs, and launches a Jupyter notebook on startup, write sudo docker run --gpus all -it -p, then 8889:8888, then -v, then the name of the directory you want to mount to the container. In my case, it's this my Jupyter notebooks directory, :/tf, then the name of the Docker image that you want to use. We're going to use TensorFlow /TensorFlow : latest GPU Pi3 Jupyter. The -p argument of this command will expose the container's Jupyter port 8888 on our host's 8889 port. This allows the host machine to access the Jupyter notebook server that is running inside of the container. The -v argument mounts our host's directory to the container's TF directory. If the machine that Docker is running on is local, then you can open Jupyter by going to localhost :8889 in your browser and copying in the token that is printed by the server when it starts up. Since the machine I am running the container on is remote, I need to do something slightly different. I'm going to forward the remote machine's 8889 port to my local 8888 port, which I can do by running ssh-n-f-l localhost 8888 :localhost 8889, and then the name of my remote user. I type in my password and enter it. Then when I open up my browser and go to localhost :8888, copy in the token generated by the server when it started up, then I can create a new notebook and check that I have access to TensorFlow 2, along with the GPUs on my host machine. So we've been able to verify that we can run TensorFlow 2 using a Docker container. When you're finished, you can stop your container running by going to the terminal containing it, pressing Ctrl+P, Ctrl+Q, then writing sudo docker container ls, extract the container ID for your container, then paste that into the command sudo docker stop at the very end. So like this, sudo docker stop, and then the container ID of the container I want to kill. This tutorial contained a lot of information. You learned how to install 3 pieces of software: the Docker engine, the NVIDIA drivers, and NVIDIA Docker, a package that allows Docker containers to access their host GPU. Having installed these, you then created a Docker container using a TensorFlow GPU Docker image. This container ran a Jupyter notebook, which you connected to remotely using port forwarding. Finally, you verified the entire procedure by importing TensorFlow 2 and checking that it could see your GPU. Great job. I'll see you in the next tutorial.
Welcome back. If you've worked with TensorFlow 1 before, you might already have lots of code written for TensorFlow 1 and are understandably concerned about all of your code becoming unusable if and when you upgrade to TensorFlow 2. The good news is that the TensorFlow development team have made the process of converting your current code to be TensorFlow 2 compatible really easy. You can find some useful information on migrating from TensorFlow 1 to TensorFlow 2 in the TensorFlow guide. If you first navigate to tensorflow.org/guide, then down the left-hand side here, you'll see an item Migrate from TF1 to TF2. On this page, you'll find a lot of useful information for TensorFlow 1 users about porting your code over to TensorFlow 2. The first item you can see here is about an automatic conversion script that has been made available to convert existing TensorFlow 1 code to be TensorFlow 2 compatible. Jerome will show you an example of using this upgrade script in the following tutorial video. The one thing I'd like to point out here, though, is that this upgrade script will make your legacy code compatible with TensorFlow 2, which will save you a lot of time and means you can continue running your code after the upgrade, but it can't transform your code to use the TensorFlow 2 syntax or idiom. It relies heavily on the tf.compat.v1 module you see here to update your code. That means that things like placeholders, sessions, and so on will still be there in your code, but they'll now be using the tf.compat.v1 module. So that's why, if I just go back to the first page, there is more information here on upgrading your code to the native TensorFlow 2 style. I won't go through all these points now, but you can see the kinds of things they're addressing, replacing session.run calls, placeholders, and so on. Down here is a really striking illustration of just how much simpler TensorFlow 2 is to use. This is TensorFlow 1 code, which creates a very simple graph that is just an affine transformation of the input, and you can see we've got the TensorFlow 1 placeholders, variable scope, down here is the session object, and underneath is the variable initializer. In the TensorFlow 2 style, this code can be written like this. And you can see straight away just how much simpler and intuitive this code is. No need for placeholders, sessions, or feed dictionaries. We're just defining a simple function that depends on variables w and b, and then running it. If you do have legacy TensorFlow 1 code that you'd like to upgrade to TensorFlow 2, my recommendation is to first run the upgrade script on your code so that it continues to work with the TensorFlow 2 installation. Then I would leave it as it is and work your way through this course. During the course, the style and syntax of TensorFlow 2 will become more and more intuitive, and after completing the course, I'm sure you'll find the information in the TensorFlow guide much easier to understand, and I think it'll become much more obvious how you should go about upgrading your code. So on that note, I'll pass over to Jerome now, who will show you an example of using the upgrade script, and I'll see you in the next week of the course.
As you just heard from Kevin, I'm going to show you how to use the TensorFlow upgrade function, tf upgrade v2. You'll see that although the upgrade function makes our original code compatible with TensorFlow 2, it does not take advantage of its shift to eager execution. What we're going to do is we're going to create separate virtual environments for TensorFlow 1 and TensorFlow 2, test our script to upgrade in TensorFlow 1, then use tf upgrade v2 to upgrade it, before finally checking that the upgraded script works in TensorFlow 2. Let's get started. We're going to create two virtual environments, one for TensorFlow version 1.14 and one for TensorFlow 2. To do this, write virtualenv -p python 3 tf1 and virtualenv -p python 3 tf2. Activate the TensorFlow 1 environment by running source tf1/bin/activate. Install TensorFlow 1 via pip install TensorFlow equals 1.14. It will take around 30 seconds to install, so you should know that my footage is sped up. Once it's done, deactivate your current environment by running deactivate. Then activate the TensorFlow 2 environment, tf2, via source tf2/bin/activate. install TensorFlow 2 using the same procedure as before, pip install TensorFlow equals 2.0. You should find that the install takes around 30 seconds. In my current working directory, I have a TensorFlow 1 script that initializes and trains a linear regression model. I provided the script in this video's resources. Download it and place it in your working directory. If you open the file, you can see that the code follows the graph and session paradigm of TensorFlow 1. When upgrading a script from TensorFlow 1 to TensorFlow 2, it's important to verify before conversion that the code runs in TensorFlow 1. Activate the TensorFlow 1 environment. Then run the script by typing Python 3 linear regression tf1.py. The printout from this script tells us that TensorFlow version 1.14 was imported successfully and that the script ran to completion. Having checked that our script runs in TensorFlow 1, we are now going to show that it does not run in TensorFlow 2, then upgrade the script using the tf upgrade v2 function. Switch to the tf2 environment. Try running the script again. It will fail, since the script contains code that hasn't been dressed for compatibility with TensorFlow 2. To upgrade the script, we're going to use the tf upgrade v2 function. To use it, type tf upgrade v2, pass the name of the file you want to upgrade to the argument in-file, which in this case is linear regression tf1.py, and pass a name for the upgraded file to the argument out file. I'm going to use linear regression tf2. The function prints out a summary of the changes it made during the upgrade. If you print the contents of your current working directory using ls, you'll see that the function has output two files, the upgraded Python file and a log file. If you open the log file, you'll see that it contains a summary of the parts of the code that have been altered. If you then open the upgraded script, you should find that it has been adapted for compatibility with TensorFlow version 2. Note that although the new code is compatible with version 2, it does not take advantage of its major changes, such as eager execution. This is an important point, since TensorFlow 2 defaults to eager execution. If you try running the upgraded script using TensorFlow 2 via Python 3 linear regression tf2.py, you'll find that it fails to run. This is because the code relies on graph and session type execution. To enable this, and to therefore disable eager execution, open the upgraded script and add the line tf.compat.v1.disable eager execution. Save and close the script. Try to run the file again. And you should find that this time it runs successfully. We've succeeded in upgrading a script from TensorFlow 1 to TensorFlow 2. You now know how to upgrade your TensorFlow 1 code for compatibility with TensorFlow 2. Hopefully what you've learned in this lesson will save you from rewriting any monster scripts you may have in TensorFlow 1. This is our final lesson of the week, so it is time for me to say goodbye. I've enjoyed teaching you, and good luck with the rest of the course. Goodbye!